Thanks for being here, guys. I've had a blast listening to all you guys talk. Learned a lot, and I'll try and close this out with a pretty short brief here. So, brief overview of what I tried to accomplish. So the goal was to create a high fidelity tilt rotor model specifically for ArduPilot Cittal. So the steps that I took were 3D Studio Max modeling, and then of course inputting the RealFlight physics, and then testing out the model in Cittal itself, kind of evaluating some kinematic equations to make them better, and then what is required from Lua management perspective, and then sort of what's needed going forward from an ArduPilot integration perspective. So you can see the vehicle that I chose is the Bell V280. So one of those is a RealFlight model and one of those is not. So I think it turned out pretty well. I was pretty impressed with the whole process. It was a kind of a fun project. So in 3D Studio Max, if you're not familiar, it's sort of a bear if you're not in that world every day. The important thing to get it into RealFlight is object naming and hierarchy. And you can kind of see here what those look like. The hierarchy is sort of important specifically for how the physics presents to you in RealFlight, so you can break apart as a wing or whatever. Some of the name matters, like the prefix, but the actual name on the end there doesn't necessarily matter as long as you know what the parts are. Pivot orientation is sort of painful. You really have to make sure that your pivots are aligned correctly, and you go back and forth on that until you import it correctly, but you figure it out eventually. One question that most people commonly have when doing this work is, can you use an open source tool like Blender? I quickly looked into this, and as far as I can tell, the answer is no. And the reason why is because Blender exports the FBX format in a binary format instead of ASCII, and RealFlight requires it to be in ASCII. I'm not an expert. I wouldn't claim to be an expert in that world, but that's what I found.
Done with Blender, just with some extra steps.
Okay.
Yes.
Okay. Okay.
Yeah, the plugin maintainer is actually in our simulation channel on Discord.
Cool. So one trick that I did sort of figure out that I think a lot of people haven't really pushed the edge on is prop modeling. And the way to do that is basically, remove the prop and model it as a separate entity, and then bring it in as a custom prop. And where the prop sits, you essentially define the prop as a plane, and whatever's in front of that plane in the origin space will then rotate. And so it looks like it's spinning, and you attach the prop in post. The TGA files. So in my development environment, typically I have RealFlight on another machine. And it took me a while to figure out why it wasn't importing correctly. And that's because the visual texture file, the TGA file, when it gets generated by 3D Studio Max, it's hard linked on the folder structure that you have on the computer that you're doing the 3D Studio Max in. So if you're bringing that file across to another machine, for example, you can simply rename the directory and do it manually in like a text editor or whatever. So if you get this far, congrats, because it's extremely painful, as most people well know. But the good news is you're basically done. So, what takes like 2 or 3 days to get here, you end up spending about 20 minutes, and then you have an airplane flying, which is really nice. One of the really nice features of RealFlight is in fact that getting the physics pretty close really quickly is super easy to do. The interesting things that I found with respect to tilt rotor in RealFlight is because it is so symmetric, the hierarchy that you end up building is very, very simple. There's very few things that you have to put in. So a symmetric wing, in this case, it's a V-tail, so a symmetric tail, and then the tilt rotor, the tilt mechanism on the end, and then attaching the motor. And it's literally one element that's just duplicated to the other side. It's done really well. In this case, I ended up going with I tried both fixed pitch propeller as well as constant speed differential collective, and that's where I got into the modeling piece of creating a custom prop rotor, and then applying RealFlight's collective pitch, and that turned out really well. You can see it in the animation as well. It works just like you would expect it to properly animate, which is nice. The collective pitch I ended up ranging out was -5 to 45 degrees. And then the constant speed part of it is just controlled by RealFlight's governor. So if there's a drop down that you can pick as an ESC governor for like a helicopter, let's say. And so that's what I chose. Flaps and ailerons. The flaps are a big part of this kind of vehicle because you want to reduce the surface area, the planform area, the wing as much as you can when the prop rotors are vertical. And so in the model, I have quite a bit of drop. I think it's like 65 to 80 degrees or so. Yeah. And then in this configuration, it's a V-tail and rudder and elevator combination, obviously. So this is what it looks like in RealFlight. I'll quickly show a video if it plays.
It's not collective on nitritis. Some inside there, there's no slide there.
That's correct. Yeah, and I'll talk about the dynamics after the video stops. Yeah. Yeah. Okay. So some of the findings I found were the kinematics that this type of vehicle require, as you would expect, a handful of mixers. As you tilt the tilt rotors forward, what was roll turns into yaw, and what was yaw turns into roll. Some of that is in the tilt rotor code in RG as it stands now, but not all of it, and it's not all complete. And so I basically configured it to the max extent that I possibly could, and then added in some of my own, which I'll talk about. But ultimately, this is the simplification that I came to, and this is, bear in mind, this is very simple, mostly for conversation sake. But you can see I've broken it down into the moments of L, M, and N, specifically roll and yaw, so L and N, and then the acceleration forces in the x-axis, so that would be out the nose, and the z-axis, which would be vertical. Those are the primary dynamics for the non-linearization that the tilt mechanism applies to the vehicle. And so I loosely put those down just to show the generic mixing there. And then if you invert those equations, let me back up one step. So alpha in this case is the tilt angle from 90 degrees down to 0. And so the ultimate goal is to figure out how much thrust you need to generate and how far you need to tilt those motors. And so in Peter's previous talk about motor mixing, a lot of the nonlinearity that he was trying to capture was at the extremes where the actuators or motors in this case are saturating. The upfront part is fairly linear in the sense that the thrust vector doesn't change. And so there's not much that you have to really linearize per se, other than a basic motor matrix. However, for a vehicle like this, before you even hit the actuator saturation, all of the controls are nonlinear. And so adding this step in significantly reduces, issues that the PID then has to compensate for. So I broke it down, into the thrust and the tilt explicitly based on those 4 commands. So your lateral acceleration, your vertical acceleration, your yaw command, and your roll commands. They're very basic here, and I don't really highlight in these specific equations, things like turning off roll completely when they're fully down. So in this case, to generate roll, you would tilt differentially the tilts. Most likely I won't do that, but it is technically represented in the math there. So you would just have if statements or just drop it to 0 heuristically in the equations that you draw up. But that's the basic kinematics of the vehicle, at least. For Lua management, this was just a quick and easy. It was relatively simple to sort of manage the bring up of the vehicle. So because it is a constant speed collective pitch, I needed something to manage bringing up the governors. And so, simple, easy fix to do that in Lua, just check for arming and throttle position and then bring up the governors. Some things that I didn't necessarily anticipate was speed scheduling the collective. As you can imagine, having that vast of a collective range, you can quickly create a massive parachute depending upon your speed. And so making sure that you schedule that based on your speed is important. Do the same thing with RPM management. When you're flying as a fixed wing, you don't need all of that RPM, so you can back it off. motor spool up management, like I said, just managing the governors. So really the goal of this whole talk and investigation was to figure out the corner cases for RealFlight, like where it's strong and where it's weak. And I found, I think, both of those. So the vehicle type that I've illustrated isn't technically supported. It's a combination of a bunch of different vehicles. So it's a quad plane, tail sitter, bicopter. And if you go to configure that, you'll quickly realize that you can't explicitly configure that directly. You've got to do a couple hoop jumping to get that done. But it does come up and it does fly. I'm suggesting, I think at this point, to create a new airframe class specifically to capture some of that mixing that I recommended earlier, because it's not as well defined as it needs to be. Some of the mixing is there for like a quad plane with where the two motors tilt forward, for example. There is some thrust compensation or tilt compensation that de-weights roll as they tilt forward and things like that, but it's not quite complete enough to have a smooth transition on this vehicle specifically. One thing that I did find that wasn't represented anywhere except for trad heli was roll to yaw coupling. So I'll back up a couple slides here. When in this specific case, it's differential collective to produce a rolling moment. And so as you can expect, like, one collective goes down and one collective goes up. And what that does is it produces an asymmetric yaw moment. And so those two modes are coupled. And so typically what you can do is you measure your roll force and then you feed that forward to correct for it. So I just created a quick little patch. It's pretty straightforward. You can see what it looks like there. But that same effect would apply in, say, like a tricopter, like a pure tricopter. So it'd be nice to have that sort of universally applied elsewhere in the control laws. It doesn't necessarily have to be this vehicle specific. There could be other uses or other vehicle types that would take that kind of a coupling. Yep.
Something that we could think about doing is genericizing some of this stuff by making actuator-based classes within motors. So instead of having, 80 motors carrying 80 motors doing carry, we can try and have another subclass of actuator with client, and then that make it a little bit cleaner to share that throughout the vehicles.
Yeah, so the question was essentially genericizing the current motor mixes to capture some of these dynamics heuristically, sort of like in the actuator itself. I guess the way I would reply to that and like push the question back onto the audience is I sort of see that as what Leonard and Bill are going to be doing in the next 12 to 24 months. As sort of like reconfiguring the whole flight law structure such that it can include more of these nonlinearities that you can specify. If you've ever used, I can't remember the name of the flight code now, but it was on a KK2 board and it was specifically made for VTOLs. They had something similar to that where you could basically define this rotation matrix in a big matrix of all the possible gains and rotations that you could ever want. And it can get pretty messy because you're basically doing all things for all people. But the good news is you can do all things. So it's complicated to set up and it's complicated to get right. But it does add a lot more flexibility. So I think the interim step for me is probably going to be to just create my own vehicle class. I would like to sit down with Peter and Tridge maybe and see if I'm missing something obvious where I could just add a couple lines of code to clean off the transitions. But I think ultimately, like where the whole RealFlight project needs to go in the future to be more robust to these kinds of vehicle types is exactly that. It's like what Leonard already sort of presented.
Yeah, the extension to that too that I did mention in that law is the potential to define some of those subclasses as Lewis groups for federal use and actually allow those books to be sent off to a Lewis group, something like that. Again, this is where that feedback from everybody that understands the programming side of things to a much deeper level could help provide that flexibility.
Yeah, that's right. And the primary goal of building this model was to have a model that we could test against, that we could test these nonlinearities in. One question I've got from a friend was like, well, why not just build the V22 or use the V22 model that's in RealFlight? I could have done that and just stripped out the physics and cleaned up the physics to be more, more accurate. But honestly, I kind of wanted the challenge of a contemporary new vehicle that just hit the market kind of thing. The V280 is the new replacement for the Blackhawk. And so I figured, getting that sort of a structure scaled down like 20% scaled would sort of give us a pretty good starting point.
Just a quick question, when I use RealFlight for this sort of thing, I'm back from just during COVID, just for sorry. 3 years ago, that version, it didn't capture the reaction forward. Due to the fact that if you had a moving motor, so it would you sort of quickly rotate, it wouldn't capture the fact that there's a reaction forward on the aircraft. And that gave probably departure from real shooting results.
Yeah, I think that's probably right. I think there's a decent reaction torque in the opposite rotation of the propeller spinning. So as you accelerate the prop or decelerate the prop.
Just when you rotate those cells.
That's right. I don't think that's represented. Yeah.
Static.
Yeah.
Static.
That's right. That's right. I think, the sort of the observations that I've made is that it's relatively good from a fidelity perspective. There are a handful of things that are poor. So a good example of something that it does really well, in my opinion, is showing the bandwidth case for a fixed pitch propeller versus collective pitch. So trying to get a vehicle like this to fly with fixed pitch, you lose your bandwidth on your roll control quite rapidly. And I'm sure a lot of you guys are, familiar with Tom Stanton's V22 work that he's doing. And he's doing exactly that. He's doing it with a fixed pitch propeller. You can get it to work. And I did get it to work in sim, but your control bandwidth is really low. And so I already knew I was going to go collective pitch anyway. So I went ahead and jumped to that step. And it's amazing how much bandwidth you recover.
So what version of RealFlight you used?
9.5.
So I was using 8 and I had
Okay.
updated the reaction torque dynamics by now. It sounds like
Yeah, I don't think so. I could validate it and check. The other thing,
Is there momentum characteristics of the propellers?
yes.
So they've got the information they need there to do it.
Yes, that's right. I think probably the most egregious thing that this model doesn't cover, in my opinion, is power absorption from the propellers, the prop rotors. So the power model for the standard fixed pitch propeller that they produce, I think, is relatively close. It seems to model something like Mark Drella's motor model and propeller model. So I think those numbers, if you put those numbers in, you'll get relatively close numbers on your power. But whenever you switch to collective pitch, I think they quite literally assume flat plane with no twist. It's speculation, but I think that's right, because the power numbers that I'm seeing are representative of something like that. And so it's sort of juxtaposing that with what you see with reasonable power numbers from a fixed pitch propeller versus, switching to collective.
Certainly wouldn't be capturing flights at all in your settings like all those effects available.
In some case, I think there's actually decent modeling there, but at least what I've seen on the fixed pitch propeller side, they do have CL curves and profiles that you can put in. I put them in for this prop rotor specifically, but the power numbers seemingly at this point aren't right. You can fudge it down, so you can set an artificial gain to lower your power numbers to get closer to what you want. But I sort of stopped there. I haven't really. I was more concerned about the GNC side and less the performance side. I'm not necessarily trying to, use the performance numbers from RealFlight to approximate a vehicle, but I was more specifically just trying to create a robust enough model that RG Pilot could use to really suss out this type of vehicle type for testing.
Did you think the prop wash onto the wing that affected that loss of efficiency, or really the force of that causes it? Would you assessment of that seemed to be about right?
So the question was, the efficiency loss due to prop wash impinging on the flight surfaces like the wings, is that modeled correctly? I don't think so, but I haven't really checked it again because the collective pitch power numbers are so far off. Primarily, I think in hover they're pretty close, but in forward flight they're not. So
you can ask on the forum. There's the key person in RealFlight is Jeremy Stevens. And I've had a private chat with him for some years now. You can also ask him on the forums questions like that, you know, doesn't always answer, but it is the primary weakness of RealFlight. It's a great system for getting quite a complex vehicle going reasonably, very quickly, and making large scale adjustments very quickly. Make this one tilt, make that one collective pitch, make this one whatever. Very good for that. But you hit a wall where you then can't, if you want to add a more detailed physics model into a particular piece, you can't.
That's right.
It doesn't have the hooks for replacing in a new physics model, a more detailed one to capture the dynamics that you really care about.
That's right.
And that's where gazebo, you know, it is potentially a lot better, but it's a higher hurdle to get that initial big going.
Yep, that's right. Yeah, I think, you know, the simulation that I've been around, at least from academically, it's almost certainly plagued by units and things. So it's garbage in, garbage out, and you've got to be really, you know, really careful with believing your own sim that you created. And so I think, you know, to your exact point, RealFlight is a great starting point because you can size up an arbitrary vehicle really quickly and get some basic performance to prove out, you know, some corner cases and control laws that aren't sufficient yet or whatever. And I think that's exactly what this did.
And fixed wing tuning is surprisingly good. I found that as long as you pay attention to the mass distribution, the deflections, the size of the surfaces, then I can usually give somebody a tune in RealFlight, and the auto tune RG produces something within around 20%. And so it's quite reliable, the tune that I give them. But that's for larger quad planes. As you go to smaller vehicles, you know, less good.
That's right.
But for like, you know, 20, 30 kilo quad planes, when I'm giving people tunes, it's just blowing.
That's dynamics too.
Exactly.
Yeah, much visibility as to what's happening.
There's usually I do a conservative thing where I take the auto tune results in RealFlight and then I like back off the gains somewhat, just to get them flying.
There's a surprising amount, like, you know, servo time constants and stuff. There's a surprising amount of modeling in there that you can do, slew rates on things, and it is quite impressive. I guess one of the last things that, you know, from feedback to Tridge is I did use QuickTune to tune it in, you know, in loiter mode, and it worked great. It got it tuned up, you know, quite rapidly. Now, that being said, that was in the collective pitch mode. In the fixed pitch propeller mode, I had to tune it manually because it was just too much. But yeah, it from the pure loiter perspective, the loiter controller on this vehicle works really well. The bicopter motor mixer works really well. Like, as long as you're not transitioning, it's fine. And even still, the transition still works. There's a couple of things that I worked with Peter on, that it basically just goes full throttle on transition. So the motors are straightforward, and you cue the transition, it goes full throttle. And so you don't have time to tilt them over, and so it just climbs like crazy. And so from the perspective of trying to hold velocity, the current configuration of quad plane, bicopter, tilt rotor, tail sitter, it doesn't capture that. But yeah,
much more cautious about giving people VTOL tuning out of RealFlight. You can have very bad results because it doesn't capture any of the vibration stuff, any of the flex of the frame. And so you very often end up with gains that are unrealistically high in RealFlight. They put it on a real vehicle with some twist and vibration and things, and their D term will be oscillating like crazy on the real vehicle, which it wouldn't in RealFlight. Fixed wing is a much better for actual tuning. As far as pilot training, it's great for VTOL, but the tune, not so much.
Yeah, and I like using it for just generic physics. So what I mean by that is the transition, like setting how like, I know I'm going to be coming in at, say, 22 meters per second for my trim airspeed. Then I can back out how far I need to start my transition waypoint and stuff like that. So from that perspective, I think is, you know, your deceleration profile for your back transition and all that, it's really good to sanity check those numbers in something like this, because all those numbers are going to be relatively close. You know, assuming your calculation of stall and all that's correct for your vehicle. But But yeah, that's proved to be the most useful for me. The last vehicle I did this on was around, I think 30 to 40 pounds, depending upon the configuration. And I didn't use it for gains at all, but I used it for all of my waypoint planning to set up my transition kinematics, and all of that worked right out of the box. It was spot on. It took me a couple of days to dial it in RealFlight, but all of those numbers transitioned over to the actual vehicle flawlessly. Well, that's all I have. If nobody has any more questions.
Okay, I got one.
Sure.
Right at the beginning, you were using a 3D modeling. I was wondering, like, I thought that in RealFlight you could already design your own airframes and stuff. I've actually never done it, but I was wondering why, would it just make it look more accurate, or like why the extra tool?
Gotcha. So, I mean, as far as I've only done this like 3 or 4 times now. The typical approach is to take something like SolidWorks or Fusion 360, and then export that as a step file or STL. I can't remember which now. And then bring that into 3CO Max or Blender. That gives you the generic shapes, which ultimately ends up being a bunch of 3-dimensional points in a big ASCII file for all of the triangles that shape represents. Oftentimes, you'll find that you'll have way too many triangles because your shape is too articulate, and you can decimate down and that kind of thing. Specifically in RealFlight, as far as I know, there's no way to draw an airplane in RealFlight. They expect you to import some shape, and then from there you can really easily outline the physics scaffolding that you saw right here. So all of the yellow lines represents the physics scaffolding. There's even a button where you can click on to essentially take the visual image that you imported, and it'll wrap the physics scaffolding for you. So if all your dimensionality and scale is correct, it'll wrap that generic shape as best as it can. Sometimes it gets it wrong, but oftentimes it gets it fairly close. So it is pretty easy to take somebody else's model and import it. There's a couple caveats to that, but you don't have to do the design work yourself either. Oftentimes getting the texture mapping to line up with the solid shape is very difficult. But yeah, that's how you do it.
On the Blender plugin, just for the record, Bob Long who's a recent dev team member, just joined the Archipilot dev team just recently. He is the author of the plugin for Blender that allows you to use a pure Blender without buying 3ds Max. You can use Blender to go from word go. And he's in our simulation channel as a recent addition to our dev team.
Awesome. Yeah, that should help a lot of people bring stuff in.
Yeah, the other thing probably worth mentioning, if you just want to try a new geometry, you don't actually have to have all your model, right? And this is probably where Randy
That's right.
is going. You just grab your plane, your little twin motor, whatever, and then you make them articulate, and you move their position, and you can sort of test it. Your model doesn't move, right? But the physics is there.
That's right. Yeah, a great example of that that I did recently for a partner was the E-Flight Virgins, or the Convergence, or the tricopter tilt rotor. Their airplane's very similar to that, almost identical, but with different dimensions. And due to their construction, they couldn't get the CG far enough back onto the VTOL motors, and they were wanting to prove out, like, is this sufficient? And so I just took that model and moved all the physics scaffolding around, and doesn't even line up with the vehicle at all. But it's representative of their airplane, and so when you see it, it looks like the E-Flight airplane, but it's flying their physics. So that's a great example, and it's super useful if you don't care about the what it looks like.
Don't care about windows.
That's right. And another great example of that is the V-22. If you look at the V-22 physics, it's basically a quadcopter underneath, and then they just tilt the quadcopter. they totally cheat. Yeah. Another cheating example I've seen in RealFlight is the Prandtl wing. I won't go into the physics of that, but it's a tailless flying wing. I found a RealFlight model that this 3D printed company makes of their model that they sell, and I was like, oh, this is gonna be kind of neat to see if RealFlight can handle a Prandtl distribution without a vertical tail. And I pulled up the RealFlight physics, and they cheated and used tails.
Yeah.
So yeah,
You can't see them, but
it's there. That's right. Well, awesome, guys. Thanks for letting me talk.